Welcome to Summarize Science, where we dive into the latest breakthroughs in technology. Today, we are looking at a way to teach AI to understand the complex vibrations of tiny mechanical systems. Most machines we use, like those inside your smartphone, rely on tiny oscillators that vibrate to perform tasks. Predicting how these oscillators will behave under different forces is actually incredibly difficult because they are nonlinear. Normally, scientists have to run thousands of simulations or experiments to see how a system reacts to every possible change. This process is time-consuming, expensive, and requires a massive amount of computing power. However, researchers have developed a method called MEv-SINDy that changes the game. This framework uses what is known as one-shot learning to identify how a system works. Essentially, it means the AI can look at just one single example of a vibration and figure out the math for everything else. Think of it like seeing a person take one step and being able to predict exactly how they would run, jump, or dance. The starting point is a single excitation configuration, which serves as the training data for the whole model. The primary output is an explicit governing equation that describes how the system moves globally. The researchers use something called the generalized harmonic balance method to break down messy vibrations into simpler parts. By isolating these different frequencies, the AI can see the hidden rules governing the motion. By passing a signal through a bandpass filter, each harmonic component is isolated and analyzed individually. This allows the AI to create a mathematical model that represents the general knowledge of the entire machine. To test this, the scientists applied it to a tiny beam resonator, a common part in microtech. Even though the AI only saw one data point, it predicted how the beam would bend and snap under much higher forces. They also tested it on a scanning micromirror, which is the technology used in augmented reality glasses and LiDAR. These mirrors rotate at high speeds and can behave in very unpredictable ways if they are not controlled perfectly. The algorithm yields a compact set of equations that faithfully reproduce the signals seen in real experiments. The AI successfully mapped out the entire behavior of the mirror using minimal data, saving countless hours of testing. What makes this so impressive is the robustness of the method across many different operating regimes. Even when the system's behavior became more intense, the one-shot model stayed highly accurate. This consistency means we can design better, more reliable micromachines much faster than before. In the future, this could lead to more precise sensors in our cars and more stable displays in our wearable tech. To recap, this paper introduces a way to use AI to find the governing equations of complex vibrations from a single observation. This one-shot approach proves that we don't always need massive datasets to solve the world's hardest physics problems. It is a huge step forward for both scientific machine learning and the future of microscopic technology. Thanks for watching Summarize Science, and stay tuned for more tech breakthroughs.